Shh, we are live. Shh. Okay, so we are doing notes for section 5.1, day 3. And I'm going to go something a little finer than this. We'll see if this is too fine. Y'all can tell me. Okay, for today's all about particular solutions. And when we say particular solutions, what that means is you've done the antiderivative, you got plus c, they give you a point, and you have to go find c. It's just doing algebra, or trig, as the case may be. All right, there are two kinds of problems. The first kind is an initial value problem. Now, in the initial value problems, they really like these for physics, the particle motion. It just means that time is equal to 0. And I'm going to write down, so I'm going to give you a problem. So this is my example 1. It's an initial value problem. We'll do a boundary value problem in a minute. For this one, we have particle motion. Oops, example 1. Particle motion. And for our particle motion, our acceleration with respect to time is equal to sine of t. And they're going to tell us the initial velocity. So in the word problems, it'll say initial velocity is equal to, and they'll tell you some value. And when you see the word initial, you need to know it's time 0. So our initial velocity, which means the time is 0, in this case is 1 meter per second. And they tell us an initial position is 6 meters. So x of 0 is 6 meters because we're only doing one-dimensional motion. That's all we do in here. We do two-dimensional in second semester. All right. So anytime you say, it says it's going to have all these words. It's going to say solve the differential equation where acceleration is sine of t. It means integrate because you're finding an antiderivative. So to find velocity at any given time, it is equal to the integral of acceleration with respect to time dt. So that means I'm going to integrate sine of t dt. What is the integral? So sine of t is somebody's derivative. Whose derivative is it? Negative cosine, right? Negative cosine of t plus c. And did they give us a point we can use? Did they give us initial velocity? We can plug that in and find c. Now, I don't know. Physics was a lot of polynomials. So y'all got used to, in physics, did y'all get used to just saying, oh, well, if the initial velocity is 1, then c is 1. Don't do that in calculus. Do you understand what I'm saying? Watch what we're going to plug it in. So if our velocity at time is, so I have now velocity at time 0 is equal to 1 meter per second is equal to negative cosine of 0 plus c. What is cosine of 0?
1.
So is that negative 1?
Yep.
Does that mean I'm going to add 1 to both sides? And therefore, c is equal to 2 meters per second. And unfortunately, you'll get so excited about finding c, you declare victory and go home, but you're not done yet. We have to write the whole equation now, right? And then we're still trying to find x of t anyway.
Right.
Okay? I forgot to write that down. Let me write that down right here. And then we're supposed to find, I'll write right here, find x of t. This is what we're trying to find. Here we go. Okay, so now we write the velocity. I'll write it blue. V of t is equal to negative cosine of t plus 2. How do I find position? Okay, way back here. when we did particle motion, I'll just write it right here. When we did particle motion, didn't we say that v of t is equal to dx dt?
Sure.
And a of t is equal to dv dt?
Oh, yeah.
And is that why we integrated the velocity to find acceleration? I mean, we integrated the acceleration to find velocity, and we integrate velocity to find position? Because we're going backwards now, right? That's off to the side. All right, here we go. So now what we're going to take is we're going to take this, and to find x of t, it's going to be the integral of v of t dt, which means it's the integral of negative cosine of t plus 2 dt. Okay. I know I don't need this negative, but I want you to tell me why. Whose derivative is just the cosine of t?
Sine.
Okay, so I don't need the negative, do I? So the antiderivative of negative cosine of t would just be negative sine of t, agreed? And what's the antiderivative of 2? 2 what?
X.
2, or t, in this case since it's variables. And then what's next? Plus c. I need to find that c. Did they give me an initial position? So at time 0, the position is 6 meters, which is going to equal to negative sine of 0 plus 2 times 0 plus c. Well, what's sine of 0? Zero. I'm showing you how tricky this can be. Sometimes it's 1, sometimes 0, right? Cosine of 0 is 1, sine of 0 is 0. So is c just 6? Oh, is that why you have to pay attention? Yep. Now, oh, let me go back up. That help? So what does that mean? It means that x of t, which is what I'm trying to find, I'm writing it really big, is equal to negative, what? Sine of t
Plus 2.
plus 2t
Plus 6.
plus 6.
That's that.
And that was easy.
It wasn't.
That was easy.
It wasn't that bad. I need a that's not that bad button, but I
Does
gotta,
that exist?
I don't know, and can probably make one.
You just say it, record it.
That was easy.
Yeah.
That was easy.
Okay. Shh, 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 shh. Okay, that's one kind of problem. That's initial value, huh? I'll show you in the calendar in a minute, okay? You got, it's like 3 weeks, or 2 more weeks after this. Okay, the next thing, I'm gonna go to a new page. Hang on, I gotta hide the, I don't need the title. Okay. Shh, shh. Now, we need to talk about another kind of problem. Shh, 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 shh. If you are given a differential equation oops, I wrote it big. And by the way, that's the class I'm taking this semester. I'm taking differential equations, so I'm going to tell you all about it. If you're given a differential equation, that means it's g of x equal to dy dx, something like that. Some function is equal to a derivative, because differential equation means a derivative equation. We just did that for velocity and acceleration, right? That was a derivative equation. Did we just integrate it? Okay, it's a little more complicated than that. Straightforward when we do those. But basically, whenever they say solve the differential equation, they mean they want you to separate the variables, and I'm saying that now. We don't get to it till later on, the separating the variable part, but I'm going to teach it to you now just so you understand the language. Because with acceleration and velocity, we've defined things, but you're going to have to integrate other things and solve for other kinds of relationships. So you need to understand this. Basically what happens is, you know how we have g of x is equal to, actually let me do this a little different. We're going to say dy dx equals g of x. And what's going on is we're taking the d of x and we're separating the variables, we're sticking it over here. It looks like we're multiplying by d of x. We're not really multiplying by d of x. Remember when we did implicit? We had to take the derivative with respect to each variable. Well, now when we integrate, you have to get all of the y's to one side of the equation and all the x's to the other so that we can integrate the y's and x's separately. And this is called separation of variables. It looks like we're multiplying, but we're not multiplying. It looks like it, right? What you end up with is, you end up with the integral of dy equals the integral of g of x dx. And all we did was to separate the dy dx into, we got y's and we got x's. And remember, if you're integrating dy, there's a 1 there, right? What's the integral of 1? In this case, with respect to y, it's going to be y ask y. So that means this is y equals to the integral of g of x dx. So when they say you're going to solve a differential equation, you're just going to integrate with respect to the variable that's on the bottom, and that's going to be equal y, or whatever else they want to call it. Okay? All right. And remember that this g of x, this is where g of x is equal to f prime of x. So that means this ends up equaling f of x, right? That's another way to look at it. It's either it's either y equals to an integral of g of x, or you can say f of x is equal, depending on what they want you to do, what they want you to find. Okay, so the other words that they have on there that tend to confuse people, y'all know how to integrate, and y'all do just fine on that, but when they use the word, different words, y'all get lost. So that was, the one was solve the differential equation. That just means integrated derivative, right? The other way they'll do it is they'll say, find a particular solution, or the particular solution, for the differential equation. And that just means integrate it and go find C. Those words translate to integrate it and go find C. So I'll write that down. Integrate and find C. So let's do an example like that. So on our first one, we did an initial value problem. On this one, we're going to do what's called a boundary value problem, which means we don't have the point at time 0, we have the point at the time, another time. So for this one, this is example 2. And you're going to solve the differential equation. For the particular solution and you're going to be given that dy dx equals 3x squared plus 1, and it's at some point 2, 4. So what does that translate to? It translates integrate that derivative and use the point to find C. So we're going to rewrite this. And I'm going to change the thickness a little bit. There we go. So we're going to integrate both sides. And what does that give us? What's the integral of dy? Y. 1y, right? Okay, what's the integral of 3x squared?
X cubed.
It's because it's 3x cubed over 3. The 3's cancel out, become 1, so it's just x cubed, right? What's the integral of 1? X plus c. And what do we need to do?
Find C.
We need to find c. So that means we need to plug in the point. Do we know that the y is 4 on our point? And our x is 2, so it's 2 cubed plus 2 plus c. Well, that's 10, right? So 4 equals 8 plus 2 is 10 plus c. That means that c,
2 cubed.
2 cubed is 8 plus 2 is 10. C is equal to negative 6.
Oh, the root is 2 squared. That's also.
Oh, yeah. You
I'm sorry. I said cubed, but I wrote squared. That was silly. There we go. Is that better?
Confused me as well.
I'm very confusing, aren't I? I have my moments. All right. So what does that mean? That means that y is equal to x cubed plus x minus 6. Is that my particular solution? And I'm done.
Yes.
That was
That was kind of easy.
That was kind of easy, huh? That was easy. I think that was really easy.
I think everything's easy for you this class.
And we're done.